Okay, I am going to record this going through each question. Make it fast. So number 1, estimate the production function for QT by employing log linear regression on Q, K, and L. So basically I did that. Got the log, the linear log of the quantity, machine hours, and labor hours, plotted that here, and then did a regression with all of this to get all of this stuff here. And then from that we were able to get the coefficient or the intercept, which is the constant, and then the two coefficients for labor and for capital, or for machine hours. And then from there you can actually create an equation, and so you just exponentiate that, and then you get this equation right here. So I got this equation here, and then we use that for a lot of these problems. This is the production function. Number 2, using the estimated production, plot total production against labor, fixing capital at the monthly average. So number 2 I did right here. Here's my graph. I just fixed capital at the average of what's over here for K, and then I just put L up whatever amount in order to just get the production function, and I used the function from up there to the production function from number 1 to plot this. Number 3, plot the marginal product of labor and the marginal product of capital. Fix each of the other variables at the monthly average, so when you're plotting them. So made that table right here. Marginal product of capital. I used this is the constant right here, and then you have labor, average labor, and capital in order for them to get the marginal product of capital. And then same thing for marginal product of labor. I did that too, and then you can see that over time that goes down. Both of them go down, but especially marginal product of labor goes down very quickly, which is going to go to show in the future that capital is better than labor. It minimizes the cost. So number 4 is the isoquant one. This was kind of hard. Plot the isoquant in capital labor space. Yep, where QT is producing, indicate where QT is actually producing, which is where their average quantity is. So I did that. I did the average quantity here, had labor go up, and then calculated K by doing a crazy equation that I basically had to do like the linear log thing, and then you have to do it to the power of the inverse, and then you get K, and you just plot those against each other. And then right here, this glowy dart one this is where we're producing. Number 5. Assume that prices are determine if QT is optimizing their input mix. So we did number 5 here. Oh, sorry, number 5 right here. And what we found out is that they're not, because there are some numbers that are supposed to equal each other, like this right here, and they're not equaling each other at all. We can see that capital is way better. So QT is not optimizing the input mix because capital is much more productive and minimizes costs. We should increase our capital and decrease labor. Number 6 is basically to actually find the minimizing cost. So I use solver for that, and this is the number I got, and then this is the L and the K. So 380 hours of labor instead of this, and then 419 machine hours is what it called for, and then you can see those two are equal, so you know that it works. That's the cost. And then for number 7, we want to do plot the iso cost with the isoquant, and it works because you can see the minimum of the isoquant hits the iso cost directly, and then that's right there where these ones hit. So right there is where the minimum cost is. You see how this matches up directly. So that right there makes sense. Number 8 is basically just showing what our current costs are, 32,926, and then what the optimal cost is from up here. and then how much money we're going to be saving per month, which is just this minus this. So, and that's assuming we get the optimum input, optimized input. Number 9, average labor. Number 9, oh yeah, number 9 was basically like how many employees do we need to cut. So with the average labor per month that we did have, they work 40 hours a week, and I assumed 4 weeks per month. So we have about 16 employees pretty much. And then from there, this is our desired labor. And if that was the case, we only need like 2 employees. So we're going to have to lay off 14 employees in order to get the desired labor. So if that's something that we want to do. Number 10 is basically like, what was the question? What are possible reasons the company is not operating? I just said maybe it's because of labor laws. Also just being completely ignorant of the possibility of this happening. And it's also possible that they didn't want to make an investment in PPE for machines. And then number 11 is, what would you do if you're the manager? If it was me, I wouldn't fire everyone at once, but I would definitely cut human capital at this point, just because if you're going to be, competing in a market, you need to lower your costs. So slowly lower the amount of employees. Instead of firing a bunch of them, we don't want to have an HR crisis. We want to keep good reputation with both employees and customers. Over time, it would get to the point where we would have about 2 workers to manage the machines, so that's optimal. And then, we could maybe expand into different areas. If we're profitable, we can expand and get more workers. So that is my thing, and there you go.